This is architecture of 8086. Uh, from this architecture, we can see that this dotted line divides the architecture in two parts. One is called bus interface unit, upper part bus interface unit, that is BIU, and lower part is execution unit, that is EU. First we will discuss about bus interface unit. Bus interface unit has an arithmetic circuit, arithmetic block which calculate the physical address of memory or IO device which is connected with the microprocessor. So how this physical address will be calculated? That physical address will be calculated with the help of these registers and some other registers located in execution unit. How it can be done, it will be discussed in detail in the segmentation process in 8086. In short, we can say that, as we know that in 8086 the total memory address range is of 2 to the power 20. That is 1 megabyte of memory can be accessed in 8086 microprocessor. This 1 megabyte of memory can be divided in 4 segments of 64 kilobyte each. Suppose that this is our 1 megabyte of memory, this 1 megabyte of memory is divided in 4 segment. This is called ES, that is extra segment. This is code segment. This is stack segment SS, and this is data segment DS. The complete physical address can be calculated using this expression: 10 into segment address plus offset address. Why it is needed? As we know that each segment register size is of 16 bit. Each segment register has size of 16 bit. So suppose that suppose that we have to calculate a physical address of a memory which is of 20 bit. Suppose that content of segment register is 10020005 H, and offset address is also 16 bit, which is located in any register of execution unit. It is given, suppose that 3520 H. So now what is the physical address? So it can be calculated by multiplying 10 into this plus this, that is it becomes 20050 plus 3520. It becomes 07532. What is the size? This is in hexadecimal 5 digits are there. Therefore, if we consider in binary, it is of 20 bits. So this is a 20-bit address of your memory location. In this way, physical address of any location can be calculated in this summer block of 8086 architecture. So it takes input from these set of registers and from this buses, where here the data is taken from execution unit. So it requires two input. One is segment address and another is offset address. So by 10 into segment address plus offset address expression, we can calculate the physical address of the device. So this process takes place in this block. Next block of bus interface unit is instruction queue. What is instruction queue? Instruction queue, you can say that it is a waiting area where you can save pre-fetched opcode. As we know that in 8085 there is an opcode fetch process where to execute an instruction, first we have to fetch the opcode of the instruction from memory, then decode it, and after that execution can take place. Then that process takes much time. Fetching and execution cannot take place simultaneously in 8085. In 8086 it is possible. So the process of simultaneous occurrence of fetching and execution is known as pipelining. What is pipelining? Pipelining is a process where fetching of the execution and execution of the instruction, fetching of the instruction and execution of the instruction can take place simultaneously. When one instruction is being executed, the next instruction which is to be executed, that's the opcode of that instruction is being fetched by the bus interface unit. So that it means this 8086 architecture supports pipeline architecture. How it is possible? So there are six locations, six register areas which are commonly called instruction queue. So here we can store six opcodes of the instructions which is to be fetched, which is to be executed in the execution unit. This is the order of fetching. This instruction fetched first, then this, then this, then this. When first instruction is given to the execution unit, one other instruction is being fetched from the memory to this instruction queue. So in this way, you can say that this instruction queue is supporting to increase the operating speed of microprocessor. The instruction queue plays very important role in the architecture of 8086.